Hello guys, thanks for tuning to my I don't know what to say. Hi there, thanks for tuning to Excel Island. And my name is Abatan Sheriffdeen and welcome back to my live stream. And as you can see, today is day 32. I'm super excited though, learning consistently every day for as little as 30 minutes, 45 minutes, 1 hour consistently for the next 100 days. So that's basically what I am doing on this channel currently. I also share some other stuff on Excel formulas and functions, and we'll probably start adding Power BI, SQL, and Python very soon. But as you can know, I'm a one-man team, so that's all I can do for now. Hopefully, in the coming future, I'll have a team that can work on this channel together and grow it beyond imagination. You get it now. So welcome back to my live stream. Today is day 32 and I'm a top rated plus freelancer and data analyst. I've been freelancing for the past 2, 3, 4 years of my life. So I've had major success on the Upwork platform. So if you're looking to become a successful freelancer, also and also do whatever you want to do from anywhere in the world, or you work anywhere you want to work from anywhere in the world based on your time zone. You're in charge of the work time that you do, the type of work you do, the one you don't do. You choose the clients you want to work with. That is the life of a freelancer or a remote worker. You get it now. So if you want to become a top rated plus or top 1% freelancer in the world or expert vetted freelancer on the Upwork platform, just like John Bonstech and a whole lot of others on the platform, then you need to get the course by my coach. The course is called Client Magnet Course. This teaching from this course made me to become a top rated plus freelancer today. The lessons from the course and the coaching I also got from the course instructor himself, being Adebi. So let me show you what being Adebi looks like. If you go to Twitter, I'll leave a link to Bengalis BE profile, Twitter profile under this YouTube description so you can check it out. So this is Bengali BE. Is a highly rated freelance coach who has made over this like 10 million plus in combined income from different freelancers. And I am also a testimonial, or I'm also one of his students also. So I've made a couple of dollars on the Upwork platform also to the extent that I became a top rated plus freelancer on the platform. If you're looking for a course like a good guidance, a highly rated course, like vetted course, which will show you how to become a top rated plus top 1% freelancer, expert vetted freelancer, then you need to get that course. I'll leave a link to the course under the YouTube description to make sure to check it out. So let me go back to what I want to learn today. Basically, when I come in to take a lesson, a couple of lessons for that day, I will have weak areas to review. So what I'll just do, I'll just review these weak areas. We have 3 weak areas to review today. And I jump back to where I stopped yesterday and I stream for 30 minutes, 45 minutes, close to 1 hour every day. Learn something new. And if you're looking for the first day, I actually started live streaming on day 11th. So the idea to start to live stream didn't come to me or didn't pop up until the 11th day. So if you're looking for first day, the 10th day, I'm sorry, I didn't live stream those periods. You get it now. So I already started live streaming on day 11 and I've been consistent since day 11 to what today will be day 32 if I complete a couple of lessons today. So let's review these weak areas together and then I jump to continue learning something new today. So I'll just click on start and it says which join will combine the tables as shown. Or this is picking everything from the right table. This is the right table, this is the left table. We are seeing 1, 4, 5, 6, 1, 4, 5. That is running everything from the right table and any matching column from the left table. So this one matches to this. We're having 1 L1 R1. This 4 matches to this here. To the right table 4 R2. You can see 4 here, but it is returning. Okay, this is the right one because it's returning everything from the right first and any matching column from the left. So that we're having 4 here, L2, L2. Is there an L2 here? For the 5, There's no 5 here. So this is having null here from the left table and 6 null. But the 4, there's a matching ID of 4, 4. Then how to, this is not matching. So I'll go for a right join there. Definitely a right join. There's a right join. So which of the following is the reason to join a table with itself? So we need to compare combination of records from the same table. Once you compare the combination of records in the table, you can join a table to itself. You are working with the cities and countries table. See the cities table. See the countries table. We have the city ID, the city name, and the country ID. So the cities table is connected to the countries table based on the country ID here. So select the code to return the output. So having city, then the country. So definitely where would that be here? Definitely a right join because return everything here. Bangalore, Chandigarh, Durban, Abu Dhabi. Then we have the city names, the country those cities are. Let's go for a right join. This is a left join. This is a full join. Wow, it's not a right join. Left join. Oh, I can't believe I showed that. I didn't pay attention. Which of the following statements is false? A right join always be, the right join can always be written as a left join. A left join returns the same result as a right join. This is false. Left joins are more common than right joins. That's correct. Left joins are more common than right join. A right join can always be written as so. A right join can always be written as a left join. So left join always return they don't return the same thing, they return different thing. So I think this is the left join. Let me check it one more time. Left join. But if it's returning Abu Dhabi, Abu Dhabi is a left join city. Um, so city is the left table. Return everything from the left. It could also be okay. City from cities, left food, left join, countries. Oh, cool. Day 32. So I just check myself up though. That is the least I can do. Inner motivation, inner self. So let's go to data manipulation. Uh, so the average male height in Europe is 178 meters. The average male height in Europe. The players table in the database includes data on each player's height. So how would you recognize them as above or below average in SQL? Okay, below average. To say select player name. So case when, definitely case when height is less than the average, that's definitely below the average. Then below average and nope, that's the case when, then below average, else above average, and as height category from players. And let's check that. That's correct. That's a simple case statement there. Can you use a nested subquery in form to extract the two hottest months from a data set of weather in San Francisco. So here is a preview of the weather table. Can you use a nested subquery in form? Okay, in the form clause, a nested subquery to extract the two hottest months from a data set of weather in San Francisco. I want to extract the two hottest months. That will be two hottest months, month of mean height. Okay, so it's nested subquery in form. So from this statement here, so select month mean height. We need to go back down here. Select extract month from date. So this one will be select. This one is definitely select here. This one is from here. We also have something here. Maximum temperature from the weather. So this one is selecting the month as MO, maximum temperature, the column from here. So I need to start the code starts from here. Select MO as okay, select the average, the month, then the average temperature as mean height from select here, extract month from date as MO, select maximum temperature from weather. The table is weather. So this is saying select the month from the date column. We are starting the month here. The month from the date column here as MO as month. Then select the maximum temperature for that month from weather as S. Go by month. So once it goes by that month, we're having two coded, two fields that will be returned. That is the month and the temperature. So from here, this one now select the month, then average the temperature that was returned here. From here as mean I, then this one select the month also. This other place select the month and the mean I here. This one is, which is the average temperature. So it should give us this one. Yes, nice work. That was quite straightforward. So Italy's country code is 10257. Which season are being identified in the case statement to determine Italy's total goals scored? So Italy's country code is 10257. It's saying which season are being identified in case statement here. So some case when season equals to 2010 2011 or season equals to 2012 2013, then home goal end as Italy's home goal. So we are summing the goals. That should be this. I didn't get that. Why? Where country ID is this? Oh, I didn't get that. I'll try it again. Can you calculate a running total of minutes spent on bicycle trips per day? Here is a preview of the trips table. Running total. The running total will be using Windows function. That will be some duration there, then over, ordered by start date, rows between, component preceding, and current row as running total. So that's check. Yeah, so that's quite straightforward. Which of the following questions may warrant the use of case statements? So creating a column categorizing purchase by over 100 and below 100. Close. Calculating the average purchase price by order. Wrong. Grouping average cost by month. No. Grouping average cost. That's what I feel. Counting number of orders made per month. You can simply use count there. The first one should be correct. So I filled this one earlier. select season. Some case when season equals to 2012, 2010, 2011, or season equals to 2012, 2013, the home goal end as weekly 2010, 2011, or 2012, 2013, 2012, so 2012, 2013, 2010, 2011. So that is a two record which is speaking there. So why is the goals with distance, but you can't see this is not fair. If I could see the table, I would ask which one is this sum, but I can't see the table. But I know it's definitely first one. Oh, let's review this last place there. So can you create a simple Windows function to calculate the overall count of bicycle decks at a station without grouping the results? Yeah, we can just overall count. So you don't want to group, you don't want to return 70, 70, 70 here. I just simply using the overall count. That will be count dogs over as total dogs. Check. So okay, we've done this before. Can you use a case statement inside a Windows function to calculate the running total of all days? So a case statement, case is using to calculate total. A case statement inside a Windows function to calculate a running total of all days, date, temperature. Select date, temperature. Then you can say this is order by date. This one is rows between onboarding preceding and current row, current row. Then I need to figure out this one here. This will be over clause there, over. Then we have a case there. That will be sum. Let's check. Try code. Oh, I didn't get mine. I'm missing something. So can you use the case inside the Windows function to calculate the running total of all days? Oh yeah, here's a preview of the temperature table. So I only return the last. I'm returning the last two. 69, 69, so 70, 76, 80. I'm missing something. Select date, temperature, sum. When the temperature is greater than 35, then 1, end. Hmm. So I'm missing something there. I want to check my Windows functions live. Rules between unbounded preceding and current to all days. Select date, temperature, some case when it's greater than some. This is quite understandable. And we need to sum those rows over. This is the required output. This is my output. I'm missing something here. What am I missing? Come on. Can you see counts there? It counts. Oh, I get it. I'm using sum instead of counts. I was supposed to be counting those one and zeros, not summing them. Figure it out. Yeah. That's a tiny difference in count and sum. If you don't get that, you definitely make a mistake. Can you use the Windows function to calculate the partition average temperature for each zip code? So here is a preview of the weather table. Use the Windows function to calculate a partitioned average temperature. The partition by zip code. So this is the zip code, average temperature. So that would be date, select date, zip code, maximum temperature. Then we now start having the and calculate average partition. So we need to say uh, zip is equal maximum temperature. Then we need to take the average clause there. And we say average. Then the over clause will come in and partition by zip code. That will give us the partition clause there. And boom, we are good to go. Oops. So we are 25 minutes into the live stream. So can you rank soccer matches in 2011-2012 season from highest to lowest by total goal and away goal? So here is a preview of the match table. So rank soccer matches in the 2011-2012 season from highest to lowest by total of home and away goal. So I want to rank that. So definitely the rank function comes first. Then the over clause comes in, ranked by home goal and away goal. So the question is it descending or ascending? From highest to lowest. That's from highest to lowest. Descending. So can you use the Windows function to calculate a partition average bicycle trip duration by start station and subtype? So here is a preview of the trips table. So here is a preview of the trip table. So can you use the Windows function to calculate a partition average bicycle by start station and subtype? Okay. Check. And we are good to go. Oh yeah, day 32 part is done. So let's take some new lessons today. We are good to go, but not yet. I'll continue from where I stopped yesterday. So I was in this chapter 2, fetching, ranking, and paging. So let's finish this chapter today as soon as possible. So ranking, let's listen.
Another common application of window functions is ranking rows according to their values. Let's learn about the three ranking functions in this video. You've already encountered one ranking function last chapter, row number. Assigning numbers to rows is one way of ranking them. Row number always assigns unique numbers, even if two rows' values are the same. It chooses some other metric to assign numbers if the value by which it's ordering is the same. Another ranking function is rank. It assigns the same number to rows with identical values, skipping over the next numbers in such cases. Finally, dense rank also assigns the same number to rows with identical values, but doesn't skip over the next numbers. This sounds a bit abstract, so let's see all three functions used at once to distinguish between their outputs. This query returns the number of Olympic Games in which each of these countries has participated. Notice that some countries, such as France and Denmark, have participated in the same number of games. How would you rank them? Let's apply the three ranking functions to see how each handles these repeated values. After wrapping the previous query in a CTE and applying the three ranking functions to them, let's see the differences in the output. Row number's output is familiar. It assigns a unique number to each row based on the provided order. If two rows have the same value, it still assigns them unique numbers, but based on an internally selected order. Rank will assign the same number to two rows if their values are equal.
The row number is different. Row number over ordered by games, descending as row number. Just assign a row number of 1, 2, 3, 4, 5, 6. Even if there's the same number there, but it is rank over order by game descending as rank number 1, 2, 2. So the same number is we have the same rank number 2, 2. Then it skips over instead of 3, it skips to 4, 5, 5 is 5, 5. So 5, 5 will skip 6 and go to 7. Okay.
Both Denmark and France are second here. After the repeated ranks, it skips over the next rank and immediately goes to 4 for Italy. Rank always skips over the next numbers if it assigns the same number to 2 or more rows. Thence rank also assigns 2 to Denmark and France, but instead of skipping the next rank, it assigns 3 to Italy. Thence rank never skips ranks. Row number and rank will have the same last rank, the count of rows, while dense rank's last rank is the count of unique values being ranked. While dense rank's last rank is the count of
So row number and rank will have the same last rank. So row number and rank will have the same rank. We have the same last rank, which is the count of the rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 2. It skips 3, but 4, 5, 5. It skips 6, 7, 8, 9. Why dense rank? Last rank is the count of unique values being ranked. So dense rank will be unique values. 1, 2, 2. It assigns same number to same figure, but it doesn't skip 3, 4, 5, 5. Based on 20. Okay, 5, 5. Hold up. The dense rank here is assigning 5 to 24 for Belgium, then 5 to 22 for Norway. That's wrong now. If you're seeing 26, 26 as 2, 2, which has the same figure number of games, then it didn't skip 3, it will maintain 3, then 4 here. Probably there's a mistake here. It's also the 4, 4. Probably there's definitely a mistake from the curriculum or from the write-up. So it's also be 4, 4 here, then 5, 6, 7. So that is a mistake. There's definitely a mistake from the course curriculum end.
unique values being ranked. What if you have some unique values being
Let me double check one more time. Dense rank doesn't skip a number. The idea of dense rank is that it's not going to skip a number here. Like rank, the rank skipped 3 and assigned 4. So rank is assuming so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what rank is doing. So because rank is skipping a number, so dense rank will skip numbers. So 1, 2, 2. Instead of skipping 3 to jump to 4, it maintains the 3. And it assigns same numbers to correspond to identical numbers there. Based on the game, 26 games, 26 games, 2, 2, rank of 2. 25 games, rank of 3. 24, 24 games, it should be rank of 4, 4. Instead of 5, 5 here. So definitely a mistake on the end.
ranked? What if you have several groups you need to rank separately in your data? This query returns two groups of athletes from China and Russia that need to be ranked by how many medals they've earned. Let's see what happens when you rank them without partitioning. The two groups of athletes are ranked here without partitioning. Because of the order by clause at the end of the query, the results are ordered correctly, but notice that the Russian athletes who won 2 medals each are ranked third.
Dense rank. There is a dense rank here. Select country, athlete, medals. Then dense rank. Over order by medals. Descending. So you can see now medals. This athlete from China has 4 medals. These two other athletes has same number of medals, 3, 3. So once this is giving a rank of 1, this is also giving a rank of, so since they are the same numbers, it is giving, they are being given a rank of 2, 2. Same thing here. rank of 4, medals of 4, got a rank of 1 medals of 2, 2, got a rank of 3, 3. So that we have 4, 3, 2, 2 here. We have 1, 2, 3, 3. This is skipping 2. Okay.
and they should be ranked second. That's because they're ranked relative to the entire table third, and they should be ranked second. That's order by clause at the end of the query. The results are ordered correctly, but notice that they rush in partitioning. The two groups of athletes are ranked here without partitioning. Because of the order by clause at the end of the query, the results are ordered correctly, but notice that the Russian athletes who won 2 medals each are ranked third, and they should be ranked second. That's because they're ranked relative to the entire table, not to the Russian group of athletes.
Hold up. Let me start
Query,
back
the
again.
results are separately in your data. This query returns two groups of athletes from China and Russia that need to be ranked by how many medals they've earned. Let's see what happens when you rank them without partitioning.
Okay.
The two groups of athletes are ranked here without partitioning. Because of the order by clause at the end of the query, the results are ordered correctly, but notice that the Russian athletes who won 2 medals each are ranked third, and they should be ranked second.
Second. Okay.
That's because they're ranked relative to the entire table, not to the Russian group of athletes.
Okay.
After partitioning by country, the Russian athletes are correctly assigned the second rank because they're being ranked only relative to the other athletes in their group or partition. If you have more than one group whose rows you want to rank, make sure to partition by the column that splits your rows into the correct groups. Practice ranking rows with the different ranking functions in the following exercises.
Okay, let's practice. Okay, in chapter 1, you used row number to rank athletes by awarded medals. However, row number assigns different numbers to athletes with the same count of awarded medals, so it is not a useful ranking function. If two athletes earn the same number of medals, they should have the same rank. Exactly. So rank each athlete by the number of medals they've earned. The higher the count, the higher the rank, with identical numbers in case of identical values. Okay, so athlete medals, we want to select the athlete medals, we want to select the athletes from here, select the athletes, then count the number of medals that athlete has won. If I run this simple CTE query, common table expression query, I run that. So this is an athlete, this is number of medals the athlete has won. So from here now, we will use this outer query to rank them. You can say select athletes, select this, select medals, then you rank. Now I want to use rank athletes by the medals they've won. So rank, so say in this, so rank each athlete by number of medals they've earned. The higher they count, the higher they rank. You can use that rank here. The higher, you could try to use rank, desk rank, or let's use the rank first. Rank order by medals. Order it by medals. Medal descending. So let's run that query. So you can see the rank. Phyllis Mikey has 22 medals. So they have unique rank. They have the medal 1, 2, 3, 4. So this is 13. They have the rank of 4, 13, 4, 13, 4. So from 4, it will skip 5, 6. You can see this is 4. This one is 5. This one is 6. It will skip that to 7 immediately. That's what the rank function does there. So you have 7, 8, 7, 7, lot of 7. It's going to skip them to the next rank. Okay, let's submit that and see if we are correct. Yep, we are correct. So now, so in the previous exercise, use rank to assign rankings to one group of athletes. In real-world data, however, you will also find numerous groups within your data, correct? Without partitioning your data, one group's value will influence the rankings of others. Also, while rank skips numbers in case of identical values, the most natural way to assign ranking is to not skip numbers. If two countries are tied for second place, the country after them is considered to be the third by most people. So rank each country's athletes by the count of medals they've earned. The higher the count, the higher the rank, without skipping numbers in case of identical values. That should be dense rank there. So if you run this query here, select country athlete count as medals from summer medals, where country is Japan and Korea, and year is equal to or greater than 2000, go by country and athlete, having count greater than 1. So if I run this city query here, oops, what's the problem? Oh, I didn't select it very well. I didn't select it very well. Hold on a minute. 1 minute here. Hello, one two. Yeah? Mo ń bọ̀. Mo busy báyìí. Ẹ fún mi 5 minutes. Ẹ ti gbọ́? Màá wá síta mo ń bọ̀. Mo ń bọ̀ ǹta ẹ ní sùúrù. Hello? Hello? Hello, Temi. Hello, one two. Okay, I'm back. So you can see, so this is the select country, athletes, count star as medals, from summer medals, where country. So this is the query. Yeah, this is the output of this query. Country, athlete, medals. So from here, and I want to rank them based on the number of medals. I can just select country, and athletes in each country by medals they've won. Okay. Select country. So now we want to rank them by the medals they've won. So rank each country athlete by the count of medals they've earned. They are the count, they are the rank, without skipping numbers in case of identical values. So what are we selecting here again? Select the country. We selected the athlete. Okay, athletes. Let's select the athletes. The athlete from here. You can say dense rank. dense rank over partition by medals order by what partitioning by country in each country by medals they've won. So partition by country, not medals. Let's run that. Let's see. And boom. So you can see this Japan. Japan. We're having Japan here to this place. Japan stop here. We're having 5-5 here. We have rate of 5, 4, 4. This one has the rank of 1, 2, 3, 3. Because you can see rank each country athlete by the count of medals they won. The higher the count, the higher the rank without skipping numbers in case of identical values. So we didn't skip numbers in case of identical values. So dense rank won't do that. If they have identical values, if I submit that, that should be correct. Absolutely correct. No errors there. Okay. So it says you have the following table: country medals: Iran, Iraq, Lebanon, Syria, Bahrain, or maybe probably South Africa or something of sort. So if you were to use dense rank to order medals column in descending order, what rank will Bahrain be assigned? Dense rank, you have 1 here, 2, 2, 2, 3. Without skipping, this will have the rank of 1. It said descending order. This will have the rank of 1. This will have 2, 2, 2, 3, 4. Hold up. Yeah, with dense rank, we have 2, 2, 2 here. Definitely 2, 2, 2. In this case, we have 3, then 4. But we say descending order, then this one should be 1. But that's not possible. There's not even an option for 1. So that means this option, there's no answer in the options there. We have 23, 19, 19, 1, 2, 2, 2, 3, 4. It can be 5. If I go for 3, let's see. Why is it 3? That's not fair. Because this is rank of 1, 2, 2, 2. Okay, it's 3 now. Okay, BHR 3. Okay, I'm taking off. I need to pay attention again. Definitely 3. So now let's talk about paging. Oh, this is the last part. So let's finish this chapter real quick today.
The third common application of window functions is paging. Paging is splitting data into approximately equal chunks. APIs are interfaces to exchange data between different web platforms, and many APIs return data in pages to reduce the size of the data being sent and make it more on demand. Also, when data is sorted by a metric, separating data into quartiles or thirds can help judge performance, since one can see whether a data point is in the top, middle, or bottom third. How do you paginate data in SQL? Enter ntile. Ntile is a window function that takes as input n, then splits the data into n approximately equal pages. Let's see ntile in action. This query returns all 67 unique disciplines. Splitting them into 15 approximately equal pages will net around 4 or 5 rows in each page. The reason why the number of rows per page isn't constant is because 67 is not evenly divided by 15, so there will be overflow in some pages. Place the previous query in a CTE and use ntile, passing 15 as n. In the result, the query's rows are split into 15 pages.
Okay. Select discipline, enter 15 over as page from discipline, followed by page ascending. Okay.
Pages, with around 4 or 5 rows per page. For example, page 1 has 5 rows, but page 2 has 4, though the results are truncated here for space. Another use for ntile is to split the data into thirds or quartiles. Here, the country medals CTE counts the number of medals each for ntile is to split the data into thirds or quartiles. Here, the country medals CTE counts the number of medals each country has been awarded overall in each set of Olympic Games. Using ntile and passing 3 as n, and ordering by the medals awarded in descending order, the query's results will be split into thirds, with the top 33% of countries by medals awarded in the top third, with the third column's value being 1, the middle 33% in the middle third, with the third column's value being 2, and the bottom 33% in the bottom third, with the third column's value being 3.
So select country, then the medals, enter 3 over order by medals. The enter is splitting it into three pages. Okay. Equal pages. Okay.
This way, you can easily label the top, middle, or bottom X% of your data.
The data.
Grouping by the third column, you can see that the top third has an average count of
So with country as medal, third as enter. So from that, can I use that query to go by average, okay, round average medals as, okay,
awarded medals of almost 600. The middle third has an average of about 23, and the bottom third has an average of 2 medals. Now that you've seen the uses of ntile in paging and labeling the top, middle, and bottom X% of your data, practice using it in the following exercises.
let's practice this last page, last query, and finish this chapter 2. So there are exactly 666. So there are exactly 660 unique events in the summer medals Olympic data set. If you want to chunk them up to analyze them piece by piece, you need to split the events into groups or approximately equal size. To split the distinct events into exactly 111 groups, ordered by event in alphabetical order. Okay, select events as distinct event from medals. So this is the medals table. So the events. Okay, so if you select distinct event, let's see that. So we have that means we have 666 rows of events in our Olympic data set. So we want to split them. Now split the distinct event into exactly 111 groups. How come 111 groups? Let's see. So let's split up the distinct event into 111 groups. What does that mean? So select events. Select events. Then enter to split that. Then 111. That should be 3. Definitely 3. Unique groups. There's 111 unique groups. Hold up. Order by order by the event also. Since we have only events column there. And let's see that. Let's run that first. So say 111 groups. Okay, let's run that one more time. I'm seeing 100 kg, 1. I want to complete that. Sorry about that. One, I want to understand what the entire function is doing there. 1, 2, 3. 1, 2, 3, 4, 5, 6. So we are dividing it by 6. We just divided this by what? By 6. So we have 6 groups each. Okay. So divided by 111. So that is 6 6. If you assign, it will go with those 6 groups. Okay. Let's see. So good. Enter allows you to make the size of your data set you're working with more manageable. Okay. I'll need to revisit or look for resources on that internet just to understand it better. So split the athletes into top, middle, and bottom thirds based on the count of medals. So splitting your data into thirds or quartile is also useful to understand how the values in your data set are spread. Getting summary statistics, averages, sum, standard deviation, so on the top, middle, and bottom thirds can help you determine what distribution your value follow. So with athlete medals as select athlete counts as medals, we are counting your the records in the medal table. For summer medals, go by athletes having counts greater than 1. So we're supposed to see athletes with at least 2 or more medals. 2, 3, 4, 5 medals. So from that, we could say select athletes and the medals, split the athletes into thirds by their end medals. That's funny. Into thirds. So split them into thirds. That should be enter and split them into 3, 3. That's exactly. Enter thirds over. Then we introduce the over clause. Then order by medals. Ordered by medals. Order by medals. Descending. Order by length of descending. So what that does is that assign 1 1 to those athletes with the highest medal. So it aside one, we are only expecting to see first, second, and third. Exactly. Let's run the code first. And so we're seeing 1 year athletes with same number of medals. 22. No, that's wrong. So we're going to split the record into three partition or three interface. Let's see. Oh, so I can't see everything. I need to understand this enter pretty well. 22. Okay. So return the average of each thought. Okay, let's see. So third so this is our enter list, having of our thoughts, enter figure. So get the average medal end in each thought. Average medal end in, okay, let's get the average. Okay. It just split this record into one based on the number of rows that we have there. Just split them into three phases, three equal parts. 1, 2, 3. Then we just say get the average, okay. Get the average medals. Okay, let's see this one. Mm. So select third from here. Select the third function here, the third row here. Select thirds. Select the third there. This third here. Then the average of third. Not average medals. The average function. Average of third. So group by third. Group by the third here. Okay, order by third. Okay, now understand the rule. And boom. So average medals. Just have one. If I want this one here, I should understand that. This is giving us the athlete with at least one medal. No, not at least. With like 2, 3, 4, 5 medals. Then we use the enter function here to group them into three parts, into three pages. Rather, oh, I need to run it from here, from this place actually. Oh, that's why I don't like city. My city is saying this is that. I want this alone. It should work though. So it's not seeing athlete medal. When my athlete medal is here. Okay. But this one here is saying third, average third. Let's run everything like this. So return the average of each third. The average medals for each splitting is at least 1, 1, 1. Can you understand that? Let's see. Because just to see medals there. Oh. Okay. Oh, okay, average medals. Okay, let me run this again. I need to go back here to the first one here. If I run this query here, so the medals there has been split into one. All this one falls on the first page. So some falls on the first page. Okay. So So now look at the medal. To get the average medals earned in each third, could select the third, but the average medals earned in each third, average medals was now start counting the average medals from here based on the third column from third, group by third. Okay. So the this enter is just splitting the rows into three thirds, three pages or three partitions. Come on, English is kind of hard and boom. So create using enter and summing statistics function because you see the difference in top, middle, and bottom thirds. So those are the top at least. That means the person at the top, if an athlete falls in the first third, second third, third third, so in the first page, at least that athlete must have earned three medals on average. Those in the second page must have earned two medals, and those in the last earned two medals also. So that's correct. Rank letter. I think I'm good. So the enter function is kind of funny, aggregate Windows function. So we'll continue this tomorrow. Alright, so thanks for staying to the end of the live stream. If you found value in this video, do give the video a thumbs up and you can support the channel by hitting that subscribe button. Also share this video and let me know your thoughts about this live streaming in the comment section. Don't forget to support the channel by checking out FCM under the YouTube description and purchasing whatever links with any links you have there. Also, check out Bengalisv on Twitter and you can come back and purchase the FCM course, which teaches you how to become a top 1% freelancer in the world and work from anywhere you are in the world and enjoy the freelancing world. Bye for now. I'll see you tomorrow as usual on the 30 what day? 33rd day learning streak. All right.